All right, so like the text says here, in practice, we rarely know the population standard deviation, especially if we're trying to approximate the population mean. Very rarely do we know the population mean, or excuse me, know the population standard deviation and not know the population mean. So when sample size was really large, this really didn't present any problem to statistician, and it was okay for them to use the sample standard deviation as an estimate. However, when we have a smaller sample size, we run into some issues. So Gossett, who worked for Guinness Brewery during the Industrial Revolution, turn of the century, ran into this problem. His experiments with tasting and hops and barley go with very few samples, and it didn't produce very accurate results when he tried to find these confidence intervals. So he created his own distribution, the student distribution, and because Guinness wanted publishing rights, he couldn't publish it under his own name. So they had to call it something different. So he has a pseudonym, then we call it the student's T distribution or the T distribution. Up until the mid 1970s, some statisticians used the normal distribution for large samples. However, we now use the T distribution whenever we use S instead of sigma. So if you have a sample mean and standard deviation, essentially what's going to end up happening when you go in to create this confidence interval is not only do we have a point estimate for the middle, but you have a point estimate for the standard deviation. So there's just like a lot of additional variability and chance that goes into that. So what we are going to do is we're going to use this different distribution, the T distribution. And the T distribution draws with, like, it takes into account that you draw basically without replacement because you can't like replace people usually as well. So we also have what's called the degrees of freedom here, where you're going to use a degrees of freedom of n-1. And it has the same interpretation as z-squared. It's still this number of standard deviations away. It just more accurately describes what's going on when we're using S instead of the population standard deviation, because you have 2 point estimates versus like just one. So there's just too much standard or variation going on. And there is a T distribution chart. What you end up looking at for your T distribution chart is this row here tells you your degrees of freedom. This row here is your confidence level. And then your associated T value is what's on the inside of that chart. Here is some more information on that T distribution if you would like to go through and read that. Essentially, it just adjusts for the additional variation that happens when you use S to approximate sigma is what you need to know here. Okay. All the other calculations are going to be the same. We just use T in place of Z so that it accounts for all of that for us, and we use S in place of sigma, but everything else in our calculations are all the same as they were as if we were using a Z distribution. So let's just jump into a problem here. So there is this project going on which is looking at the scope of industrial pollution in the human body. Industrial chemicals may come through the body through pollution or in consumer products. And so a study was done, it looks like in 2008, where they tested cord blood samples in newborns in the United States. And so cord blood is through the umbilical cord. It is collected directly after birth. There is nobody hurt in the process of any of that. In fact, a lot of times people will store cord blood because they think it has like really unique powers and things of that nature. So they were tested that for all these different compounds, And then what they looked at is the number of these compounds that were found in the infant's cord blood. So it would have been transmitted to them through the mother, and then through the umbilical cord, and that's where they would have found it. So we're going to use this sample data to construct a 90% confidence interval for what we think the true mean is going to be. So we're taking this sample of size 20, and we're going to say, like, what do we think for all newborns the true mean industrial chemical exposure is, if you will. So let's pull up a split screen again with StatCrunch. Okay, and I'm going to input this data. And the only thing that's going to be different here is I'm going to use the t-distribution instead, and then I'll go through and kind of show you some of those calculations. Okay, so you'll go under stat and then t-statistics. Here, we're just doing one sample, and I have all the data. This is where it is stored. I want to do a confidence interval of 0.9. Please show the critical value, and I don't need any of those things, so let's compute. Okay, so this tells me that my sample mean is 127.45. And see here how it says standard error? That's not this. Standard error is S over square root of n. So whatever the standard deviation is, it already divided it by the square root of n for us. And let's go ahead and just go to there. Okay. So our T with degrees of freedom 19 is usually how we write that. Sometimes you'll like put it in parentheses and put the T like that, but like the little subscript is fine. Degrees of freedom of 19 is 1.729. And then remember these two calculations here, that's what goes into your margin of error. So margin of error would be equal to that T times the standard error. And then we take that number, whatever that number is, 127.45 plus or minus the margin of error is what gives us this interval. And so we are 90% confident that the true mean number of pollutants in infant cord blood is between, let's just round this, 117 and 137. And that's it.